Okay, so as I said, after the Galileo, Newton followed his work, and Newton was in the UK, London. So from Italy the work shifted to UK, okay, that is in London. The Newton was an English mathematician and physicist. Okay, the Isaac Newton, you have heard this term a lot of time. One of the most famous physicists, one of the most famous mathematician in all times, okay, of all times. So Newton was the person, and you studied that he discovered force and laws of motion. Okay, the laws of motion means he discovered the laws which every object follows whenever it does some motion. Okay, so he discovered laws of motion, which you have studied in the chapter Force and Laws of Motion. Okay, first law, that every object continues to be in motion, or every object continues to be at rest if a force is, unless a force is applied externally. Okay, the second law, that force is equals to mass into acceleration, and the third law, that every action has equal and opposite reaction. These are the three laws that you have studied. But Newton, even after discovering this type of law, even after giving something very crucial, some of the biggest discoveries of all times, even after discovering this, he was a bit disappointed. Okay, Newton was a bit disappointed, and the reason that he was disappointed is there is a belief around him, there is a belief in the world that whatever the laws that Newton has given, laws of motion, they are applicable only to the terrestrial objects. It was believed that the laws of motion given by the Newton, they are applicable only on those objects which are on earth. Okay, it means these laws of motion are not applicable to the sun, to the moon, to the planets, or to the other heavenly bodies. It was believed like this. Okay, and because of that, Newton was a bit disappointed. He said that he first used to say that every body in the universe follow his laws of motion, but he was not able to prove this. Hence, everyone used to believe that laws of motion are applicable only to objects on earth. Okay, so it was believed these laws are applicable only to objects on earth, only to the objects which are present on earth. This is a basic belief that people have at that point of time. Okay, now since Newton was very disappointed, so he was continuously thinking of the laws, he was continuously thinking of the flaws that he made in these laws of motion, that why they are not applicable to heavenly bodies, why they are not applicable to moon, why they are not applicable to sun. He used to think about them continuously. Then what happens is, once in his vacation, when he was on vacation, he was sitting in a garden beneath an apple tree. He saw an apple falling on his head. Okay, what happens is, he was sitting in a garden and an apple falls on him, and just by observing the apple, he thought that why this apple fall towards the earth, why does apple fall down, why do not fall up, why do not go in the sky, what is happening, why it is so that once this apple, it falls from the tree, it falls down on the ground, why it is happening. He thought about it, and he continuously think about this particular phenomena, that whenever he throw a ball upwards, it comes down, it comes again to the ground. And by thinking on this phenomena, he said a very important point. He said that earth applies a force on every object. Sorry. He said that earth applies a force on every object towards itself. Okay, He said that apple falls down, the reason is that earth is pulling this apple towards itself. Okay, if we throw a ball, that ball will fall again on the ground. The reason is that earth is again attracting, is trying to pull that ball towards itself. This is what the concept Newton said. What happened is, after giving the statement, he applied this concept on motion of moon's motion. Okay, so he simply said that earth is applying a force, but he do not know what kind of force, why earth is applying a force. He simply said that earth attracts every object towards itself. Okay, then he applied this same concept on the moon's motion. Okay, he tried to study the motion of moon, that why it is like that. Motion is the moon is moving in an elliptical orbit, why moon is revolving around the sun. He tried to figure out this, and based on this statement, he was able to successfully answer the moon's motion. Okay, he was successful in answering the reason behind motion of moon. He was successful to answer the reason behind this elliptical motion of moon, that why moon is revolving around the earth. Okay, after that what he did is, he then applied the same concept on other heavenly bodies. Okay, he again tried to apply the same concept on other heavenly bodies, that is on the sun, other heavenly bodies like planets, okay, other galaxies, other suns and everything. And he found that the statement that he said, that earth is attracting everything towards itself, he applied the same concept, and again he was successful in explaining the motion of other heavenly bodies. Okay, he was able, by using this concept, he successfully explained the motion of other heavenly bodies. So just imagine how the situation is going on. First he discovered laws of motion which were believed to be true on only on the terrestrial objects, only on the objects which are present on earth. Then in one vacation he was sitting below a tree, okay, an apple falls on him, and just by observing the fall of this apple, he discovered something which is applicable to the whole universe. Okay, just see the imagination power that he applied. Just by observing the fall of an apple, he discovered a concept which is applicable to all objects, all the bodies in the universe. Okay, and by using this concept he was successful in explaining the motion. He was successful in explaining that why the planets revolve around the sun, why the planets have satellites, that is natural satellite like moon, why the moon revolve around the planets, and all these concepts. Now based on his observation, based on his explanation, without any reason, okay, just remember this, without any reason, he gave a law which is known as Newton's law of gravitation, or we call it as universal law of gravitation. by his observation, by his experimentation, he simply said that there is something which is known as Newton's law of gravitation or universal law of gravitation. He gave some law which is applicable to all the bodies in the universe. Okay, he gave a very important law which can very easily explain the motion of every body in the universe, including humans, including all the things which are existing on earth, including the sun, including other galaxies, including every body, every matter in the universe. Okay, every matter in the universe is governed by some law which is given by the Newton, that is known as universal law of gravitation. The law that he gave, this Newton's law of gravitation or universal law of gravitation, there is no reason. Okay, Newton was not able to justify, Newton was not able to, he was able to justify, but he was not able to give any reason that why this law existed. Okay, so Newton not able to give reason for existence of this law. Okay, he was not able to give reason that why this law is existing, why this is happening, why there is gravity, or why earth is attracting any body towards itself, why it is happening, why the sun is attracting other things towards itself, or why other heavenly bodies. Okay, so these are something which were discovered later on by the Albert Einstein in his theory of relativity. He discovered that why gravity exists. He gave some concepts that there is a fabric of space and time, and in this fabric of space and time is basically the gravity, and there are various other concepts. Okay, quantum physics is the field, modern physics is the field in which the theory of relativity was given by the Albert Einstein, and he discovered some of the concepts. Okay, but we will not go in that concept because that is beyond our scope. So till this point we studied that how the field of the solar system, how the field of gravitation was evolved. Okay, it's not like it is like not the work of a single person. It continued, it started from the Greek civilization and continued till London, okay, United Kingdom, UK, and it followed after that also. It's not like that Newton discovered something and that's the end. There are various other scientists who followed the work of Newton and discovered some new important things. So till this point we studied that there is something which is known as universal law of gravitation. Now we will understand what is this law, and please remember there is no reason. Okay, Newton was not able to give reason why this law existed. Our task is just to study this law. We will just study this law, we will understand its statement, we will understand its mathematical formula, and we will solve some of the important questions based on this universal law of gravitation. Okay, so first you note whatever you want to note down in your notebook from this, whatever I have written. Okay, after this we will study this universal law of gravitation. Okay, so we basically understood what is the history of the development in the field of gravitation. Now we will see the law which was given by the Newton, which is named as Newton's law of gravitation. Okay, Newton's law of gravitation, or we can say it as universal law of gravitation. This law states that each and every body in this universe which has some mass attracts other bodies towards itself. this is known as the universal law of gravitation or the Newton's law of gravitation. Newton said that in this universe, every body which has some finite mass, attracts another body towards itself. Okay, it is happening with every body. So when the apple it falls from the tree, it is attracted by the earth, and since earth and apple both are the bodies which has some finite mass. So imagine this is the earth, okay, and there is a tree on the earth like this, From this tree, what happens is an apple falls from the earth towards the earth. This is the apple. So what Newton said is that this apple and this earth both are attracting each other towards itself. He said that this is the law of gravitation. This is the law of universal law of gravitation. He said that apple attracts earth towards itself and earth attracts apple towards itself. I am attracting you towards myself and you are attracting me towards yourself. This board is attracting me towards itself and I am attracting this board towards myself. So you may feel that what is this, what nonsense it is, am I attracting anything towards myself? This wall or this board is attracting me towards itself. Is it happening? Is it really true? Do you feel this? No. You are not able to feel this. Okay, you are not able to feel the force of attraction applied by this board or applied by your computer towards you. Okay, you are not able to feel this. The reason is Newton said this force is very, very small. It's not a huge force. It depends on something which we will understand by the mathematical formula. But he said that since apple and earth both are attracting each other towards themselves, but the mass of earth is very large, earth is a very huge object, that's why earth will not move towards the apple. What will happen? Apple will fall down on earth. Okay, try to understand this concept. Earth and apple both are attracting each other towards themselves, but since earth is a huge object, it has a very large mass, hence it will not get attracted, it will not move towards the apple, rather apple will move towards the earth. So this is the law of gravitation, that every body in this universe is attracting another body towards itself. It means moon is attracting earth and earth is attracting moon. So you may feel that why, if it is true, then why the moon is revolving around the earth? Why it is not like that moon is falling on the earth? Similar way, sun is attracting all the planets toward itself, okay, and all the planets are attracting sun towards themselves. So why it is like all the planets do not move inside the moon, move inside the sun? Why it is like planets are revolving around the sun? Why they are not moving towards the sun? Why it is happening? You may wonder this type of question. All these questions were answered by universal law of gravitation. Newton said that yes, each and every body is attracting another body towards itself, but the force that is applied, by each body depends on its mass and its distance from the other body. He said a very important phenomena, that the force applied by one body to attract another body is dependent on its mass and it also depends on the distance between the two bodies. He said that the force that is applied by each body is not a constant force, it used to vary. it is different force, it is different for different bodies, because this force is dependent on their mass, it depends on their distance. You can see moon and earth, there is a huge distance between moon and earth compared to the distance between this apple and earth. So that's why what is happening, earth is applying more force on this apple, that's why apple falls on the earth, but earth is not able to apply a large force on the moon, that's why moon is not falling on the earth. Okay, try to understand this concept. If I throw a ball, okay, if I throw a ball, since ball is close to earth, earth can easily attract this ball and the ball will fall down on the earth. But since moon is far away from the earth, what will happen? Earth will not able to apply a huge force on the moon, and that's why the moon is not falling on the earth. And there are various other concepts also related to the centripetal force, centripetal motion, the circular motion of the moon, that we will understand later on. But at this point of time, we will understand the law of gravitation, and that is each and every body in this universe attract another body towards itself. Okay, I am standing here, I am attracting the chair kept at this place, I am attracting the camera in front of me, I am attracting everything around me. Okay, I am even attracting moon, I am even attracting sun, I am even attracting a fly moving around in the around me. But why it is not like that everything is falling on me? Because the force that I am applying is very less. The force that I am applying on other objects is very, very small, and that's why we are not able to feel the force. Okay, Newton precisely gave a mathematical formula which governs this law of gravitation. Newton said 2 points. The first thing that Newton said is law of product of masses. The first thing that Newton said is law of product of masses. Let's try to understand this. He said that, for example, this is a body M1, okay, this is an object M1 and there is another object M2. Now, according to law of gravitation, these two objects, they have finite mass, they should attract each other towards themselves. Okay, it means M1 will try to attract M2 towards itself, okay, by applying a force F12. Okay, let us name this force as F12. What is F12? It is force applied by mass M1 on M2. M1 is trying to attract M2 towards itself. Okay, M1 is trying to attract M2 towards itself by a force F12. Now, according to Newton's third law of motion, every action has equal and opposite reaction. Since M1 is trying to pull M2 towards itself with this force, M2 will also try to pull this M1 towards itself. Okay, like this, and this is, let us say, F21. So I assume F21 is what? F21 is the force applied by M2 on M1. F12 means force applied by 1 on 2. So it means both of these bodies are trying to attract each other towards themselves. Newton said the force between the two bodies F is directly proportional to the product of their masses. It said that the force applied by one body on the other is directly proportional to product of their masses. It means, consider this example of apple and earth. What will happen? The force between this earth and the apple, it is directly proportional to mass of apple and mass of earth. It will directly proportional to product of these two masses. Okay, so it means if the apple is a bigger apple, it has more mass, then force would be more. If the apple is a small apple, then if it has a less mass, then the force would be less. But in this situation, I am considering, let us say, M1 and M2. So their force between the two objects will be proportional to their product of mass. And the second point that he said that is inverse square law. He said a second point, that is inverse square law. Now what is inverse square law? Consider these two objects. As we can see, the Newton said force applied depends on mass and also the distance between the two objects. Let us say the distance between this m1 and m2 is r. Okay, let us say the distance between the two objects m1 and m2 is r. So Newton said that if this distance increases, the force will decrease. That is, this force is inversely proportional to distance between the objects. And in actual, by using some experimentation, by calculating some of the forces, he said that force is inversely proportional to the square of distance. This is known as the inverse square law. He said that in the universe, two bodies are attracting each other towards themselves, but the force of attraction between them is directly proportional to the product of their masses, okay, and it is inversely proportional to square of distance between them. So it simply means if distance is become twice, the force will reduce by 4 times. Okay, if distance will become 3 times, the force will reduce by 9 times. So as the distance increases, the force will drastically decrease. This is how the Newton gave the concept, that is inverse square law. Now by combining the two laws, Newton said that force is proportional to product of masses and inversely proportional to square of distance. This is the universal law of gravitation. Now since there is a proportionality, what we do? We used to introduce some constant and remove this proportionality and introduce an let us say what we can say, that is equality sign. Okay, so to introduce an equality sign, we have to put some constant. Okay, so this formula, this equation becomes f is equals to, okay, if I remove this proportionality and put any is equal to sign, I have to introduce some constant. This will become f is equals to g m1 m2 upon r square. This is the universal equation of gravitation. This is known as the universal equation of gravitation, that is force is equals to g m1 m2 upon r square, where this g stands for universal gravitational constant. Okay, so this is the concept that Newton gave. This is known as the universal gravitational constant. This is the value, this is the name of this constant g. But the interesting point is, Newton was not able to discover, Newton was not able to find out the value of g. It was founded by the Henry Cavendish, another scientist. Okay, so we will also understand what is the Henry Cavendish did to find out the value of g, but Newton was not able to find out the value of g. Newton only gave this equation that f is equals to g m1 m2 upon r square and named it as universal equation of gravitation. He said that all the objects in the universe follow this equation. They attract each other on the basis of this equation. Their force between them is directly proportional to the product of masses and inversely proportional to the square of distance between them, and this is a constant. This is a universal gravitational constant. Now what is universal gravitational constant? It is a constant which is constant throughout the universe. It's not like that in our galaxy the g will have some other value, and if I move to another galaxy the value of g changes. It do not happen. What will happen is this g will remain constant throughout the universe. It will never going to change. This is what we call as the universal constants. Okay, so this is the basically the universal law of gravitation or the Newton's law of gravitation. So first to note this, and then we will see what is the value of G, and we will analyze this G and see the unit of universal law of gravitation. Okay, and also we will see some other important concepts as well. Okay, so first you can note this.